In this video, I will discuss this question from GATE 2016, question number 45. So a simplified energy band diagram of an intrinsic semiconductor at thermal equilibrium 300 Kelvin is shown. So which one of the four columns correctly represent the listed parameters? So first, let us consider what is an intrinsic semiconductor. This means pure semiconducting material without any defects or impurities. Example is pure silicon or pure germanium, these materials. So now, what is the band, energy band structure? So if we consider two atoms that are very far apart, then they will have their, suppose this is atom 1, this is atom 2. So when they are very far apart, the electrons will have their isolated energy states. So when they start coming close together, then what will happen? So when the electrons come close, they start interacting with the electrons and nucleus of other atoms. So then what happens? One energy level splits into a number of closely spaced energy levels. So this is called bands. Suppose for example, this is our 2s1 energy level when the atom is isolated. So here in this axis we will have energy, and in this axis we have interatomic separation. So when the atoms come close together, this one energy level splits into a number of closely spaced energy levels. So these are what we call energy bands. So what is conduction band? So conduction band is, this contains free electrons that can take part in electronic conduction. Similarly, valence band, so I will write here. This contains electrons that take part in bonding. So now let's go back to the question. Here, this is our conduction band, and this is our valence band. Okay. Sorry. So what is the band gap here? That is this energy difference between the bottom of the conduction band and the top of the valence band, that is delta E1. Okay, so band gap is delta E1. Now next, electron affinity. So what is electron affinity? This is the energy difference between the bottom of the conduction band and vacuum level. Okay, so in the question we'll see. So delta E2, this is the vacuum level energy, delta E2, and this is the energy level corresponding to the bottom of the conduction band. So what will be the electron affinity? That will be delta E2 minus delta E1. Okay, now work function. So what is work function? This is the energy needed to remove an electron from a point to a point in vacuum. Okay, so simply this is the difference between the vacuum level energy minus Fermi level energy. So the vacuum level here is delta E2 and the Fermi level is this is our Fermi level. So this work function will be delta E2 this whole minus this much, this is delta E1 by 2. So column 2 we have all the right answers, so the answer for this will be column 2.